This video introduces restructuring SAS datasets, long to wide. There are two ways to think about how we might want to restructure data. The first way is where we read in multiple observations per patient and write out one observation per patient. And this is what I refer to as going from long to wide. The second way is where we read in one observation per patient and write out multiple observations per patient. In this second way of restructuring data, I refer to this as going from wide to long. So here is an example of some data. And sometimes we need to restructure a SAS dataset to do the analyses we want. In a patient setting, information will often be stored on a patient visit level. That is, each observation represents a visit for a patient. In this example, each patient has 3 observations with a visit code, the date of the visit, and patient's weight that was recorded at the visit. This structure is useful for some things, including entering the data into a database. But what if we want to compute the average weight across visits, or the change in weight between 2 visits? Well, to do that, all the weights for a patient have to be on the same observation. So we need to have a way to restructure the dataset so that all the data for a patient is on the same observation or row. So here is an example where we have a lot of observations for a particular patient, in this case 3 observations for each patient, and we want to turn this type of data set into, instead of being a long data set, meaning lots of observations, into a wide data set where for each patient we have all the information on one row. So we want to collapse the data so that all the information is contained in one observation. To collapse multiple observations per subject to a single observation per subject, there are 3 possible methods to do this that I'm going to be talking about. One method is using PROC MEANS, and so it's going to make use of the output statement that we talked about earlier this week. The second method is a method that I call within the data step. And the last method utilizes a SAS utility called PROC TRANSPOSE. So in this first method using PROC MEANS, basically what we are going to do is we are going to summarize the individual observations per patient into one observation per patient, which is just a summary measure of those individual observations. And here we have a data set, and this is going to be the data set that I am going to use in the SAS demonstration video, that deals with patients who were depressed and given a drug treatment. And the drug that they were given, IPL, stands for iprimamine. And the HDRS, the other variable that I'm using here, is the Hamilton Depression Score, which is looking at the change from baseline. And we have data recorded at week 0, week 1, week 2, and week 3. And there was a baseline measurement that occurred prior to week 0. And so if we use PROC MEANS and an output statement, notice we have in our new data set just 2 observations, the 2 patients, 101 and 103, and we had the mean levels of the Hamilton Depression Score and the mean level of the iprimamine drug plasma level. This just provides the summary measure across all the weeks for that particular patient. So there are some limits to just using the output statement from PROC MEANS to collapse and get a single observation per patient. In the method that I call within the data step, here we are taking this data that was recorded over 4 weeks, and we're turning our data set into a wide data set that captures all the information for a patient in a single observation. So what we've done is we've taken the 4 weeks of information and we've turned it so that we have variables HDRS0 representing week 0, HDRS1 representing week 1, HDRS2 representing the Hamilton Depression Score in week 2, HDRS3 representing the Hamilton Depression Score in week 3. And the same we did with the eprimamine levels. There are several ways to do this. I will give you the most general way, and I will also be introducing some new statements that we can use in the data step to allow us to do this restructuring. The program code to do this, although fairly short, requires understanding of these new statements and how the data step works. I'm going to provide an outline of the structure of the program, and then we'll take a look at the program itself, as well as look at it again in the SAS demonstration video. This is a little bit more complicated programming than we have done before. So the program is going to flow as follows. First of all, we're going to sort our data by patient and week. Then we are going to read in the first observation for a patient and create new variables to hold the first HDRL and IPL values. We will not output this observation yet, but go back and read in the second observation from that patient and create new variables for that observation with different names than for the first observation. And we will continue to do this until all the data for a particular patient is read in. Only then will we output the observation to a new data set. We will continue this process for all of the patients. So let's look at the code to do this. So here we have our usual set statement with a by statement following. And this is different from a merge. Remember, the set statement brings in an observation from a SAS data set. If we follow this with a by statement, then SAS, in addition to bringing in the observation, creates two special logical variables named in our case first.patient and last.patient. First.patient is set to 1 when SAS is processing the first observation for a patient. So that would be our week 0 data. Similarly, last.patient is set to 1 if SAS is processing the last observation for a patient, or in this case our week 3 data. So with the first dot and last dot special variables, we can know if we are processing the first or last observation from a patient. Another statement I'm going to introduce is the retain statement. The retain statement tells SAS not to reset the variables listed to missing when SAS goes back to the top of the data step. We need this statement, otherwise we would lose the information from the previous observation, because by default SAS sets the new variables to missing between loops of the data step. However, because we do this, we will need to set these new variables to missing when a new patient is processed. This clears out the previous patient's data values. If we did not do this, we might use the previous patient's value for the new patient. So the retain statement is a way of holding the data values when we're processing a particular patient. But once we have processed one particular patient, we need to then clear out those variables, set them to missing again when we start processing a different patient. And we'll see this more clearly when we look at the SAS demonstration video. Continuing with the program, we next define new variables to hold the values for the Hamilton Depression Score and the eprimamine level depending on the week. So we're going to use a series of if-then statements to accomplish this. The do keyword is associated with the end keyword. So we have these do and end statements. The statement if week equals 0, for example, then do, tells SAS to process the statements that follow up to the end statement. Thus, when week equals 3, then the two statements in between the do and the end will be executed. Here, HDRS3 and IPL3 are assigned to the variables HDRS and IPL. Note that only one of the do-end statements will be executed for each observation. Which one depends on the value of week. The last statement tells SAS to output the observation with all the new variables. So only when we are done processing the last observation are we going to output that observation. So here we use the special SAS variable last.patient. If we're not processing the last patient, the program goes back to the top of the data step and processes the next observation from that particular patient. So again, this is the code that we're going to see in the SAS demonstration video. So if we combine all this code together, this is going to allow us to output a single observation per patient that includes all the data on one row. The third way that we can restructure our SAS data set going from long to wide is with a procedure called PROC TRANSPOSE. This procedure interchanges rows and columns of a data set. And this works well if you have only one variable to transpose. However, with multiple variables, it requires multiple PROC transposes and/or also multiple data steps, making it perhaps more complicated than the method that I was showing you previously. In general, if SAS has a utility procedure such as PROC TRANSPOSE, that can help you do the hard work. However, the data step processing will also be a more general method without some of the limitations of PROC TRANSPOSE. So basically what we're doing here is we're taking our old data set, our original data set, we're using our out equals statement to create a new data set, and we are going to basically invert our rows and columns. So here are the specifics to PROC TRANSPOSE. First of all, you have a by statement, which is used for grouping variables that you want to keep as variables. And then there's an ID statement that names the variable whose formatted values will become the new variable names. And finally, there's a var statement that names the variables whose values you want to transpose. So here is some code, this data that deals with the Hamilton Depression Score. And we're interested in transposing this data set, and we're only using the variable Hamilton Depression Score. What we're basically doing is we're taking the variable HDRS and we're concatenating it with the week. Remember, week goes 0, 1, 2, 3 to create a new variable, HDRS 0 for week 0 Hamilton Depression Score, HDRS 1, which is week 1, and so we're actually transposing the data set so that instead of having patient 101, week equals 0, HDRS equals -8, we've transposed it and created this new variable, and this is all done with the transpose procedure. And this works very well if you only have a single variable to transpose, but if you had more than one variable, as I showed in the example where we worked with the data step and we had the variable at mean level as well as HDRS recorded weekly, it's more challenging to use PROC TRANSPOSE for that. Now view the SAS demonstration program long to wide.